Good morning, good afternoon, everyone. We're going to start in just about 30 seconds or a minute. Just let any last minute stragglers connect and jump on. Make sure everyone gets the entire presentation. So get yourself settled, grab a glass of water, a cup of coffee, and we'll be with you in about 30 seconds. All right, Russell, you good to go?
Yeah, can you hear me okay?
Yeah, we're good. So hello again, everyone. Good morning, good afternoon. My name is Chris Dorn. I'm a technical sales specialist for Global Test Supply. You can't see me at the moment just because I'm having a little bit of technical difficulty with my camera. Hopefully we can have that resolved. If not, you'll be seeing our presenter, Russell, right now and at the end of the presentation. So thank you for joining us for this webinar via our Global Test Supply University. Today's topic is the importance of condition monitoring and its solutions with FLIR. Throughout the presentation, we ask that you kindly mute your microphone. Presentation will be anywhere between 40 and 45 minutes, and we'll allow 10 to 15 minutes or however much time is remaining for Q&A. So we definitely encourage you to send us all the questions that you have. Take advantage of having an expert like Russell with us today. So use the chat feature throughout the presentation as well as the allotted Q&A time at the end. And we'll get to all of that at that point. So Global Test Supply has been working closely with FLIR for many years. We pride ourselves on being a leading distributor. This is a result of our dedication to offering you our product expertise, service, and competitive pricing. As mentioned just a couple seconds ago, today's webinar is presented by Russell Hall. He is based in Wisconsin and has been a channel partner manager with FLIR for the past 2 years. Russell, I will turn it over to you.
Awesome. Thanks, Chris, for the introduction, and Global Test for setting this up and getting some folks on the line today to talk about condition monitoring. So we'll talk a little bit about why you want to do condition monitoring and some of the solutions that FLIR has to help you out to make sure that your facilities are up and running and you have as little downlines as possible, and you get the most out of your equipment. So with that, we will get rolling. So a quick agenda. What is condition monitoring? The life cycle of equipment, and then we'll dig into a little bit of some of the indicators of or the different ways you can do condition monitoring, be it vibration, ultrasound, and then other predictive preventive maintenance solutions like thermal imaging cameras. And then, as Chris said, we will have a Q&A session at the end. So what is condition monitoring? It's the measuring of specific equipment parameters, noting signs of any significant changes that could be indicative of an impending failure. So as you have different equipment or machinery in your facility, you really want to do this with your critical assets. The things that if you're making 1,000 widgets a day and this machine goes down and now you can't make your 1,000 widgets anymore, you're going to have a bad week, a bad day, right? Because that's lost money. So improve safety and sustainability, improving productivity and quality, lowering your capital and operational costs. So if you can predict and stop failure from happening, obviously you're going to save costs. And then also lowering your business risk, be it to the machine, to the equipment, to the assets themselves, and also to the people inside of your facility, right? Making sure that we keep them safe. So there is what we call a depth chart, and this is the monitoring of the life cycle of different equipment. So it's commonly used to show how equipment fails and where a technique can be expected to pick up the failure relative to other techniques. So the D here is the original design of the piece of the equipment, for a motor, for example. I is the installation. So that's you buy a piece of equipment, it gets delivered, you install it, and as you're installing it, you're doing precision installation, laser alignment, all of that good stuff. You're bolting it to the ground correctly to make sure that it doesn't move and is good to go. Then you get to the P, where the P is the point at which failure can be detected. So after you've had that equipment for a little while, right, eventually it's going to start to wear and tear, maybe improper use, those type of things, where that equipment is ultimately going to start potentially degrading over time. And then you have F, where it's your functional failure. So if something goes undiagnosed for way too long, then your equipment is going to have no value, going to die, burn out, break, whatever, and you're going to have to do a major repair or replacement. So we'll dig into these different areas kind of one by one. One of the examples that I like to give that maybe makes more sense to everyday consumers, right, is it's like buying a car, right? Owning a car. You buy a brand new car off the lot. It only has 17 miles on it from different test drives that even you did, right? So you buy that car, it's brand spanking new, it's in its original design, or even in that installation part where you have the precision maintenance, right? It just came off the factory from Ford or Toyota or GM, whoever it is, came off that factory, put it on a trailer, delivered it to the dealership near you, and now it's yours, right? So you expect that car to operate 100% as it should. You hit the gas, you go forward. You hit the brake, you slow down. Your windows still work. Your radio still works. All of that. It's in pristine condition, right? So now we get to where predictive maintenance can begin to be detected, and there's different techniques for this. So some of the early indicators of your equipment needing repair or replacement, or even just a little maintenance, is ultrasound. You could have ultrasonic spikes, vibration analysis, and oil analysis. And if we talk about that car, again, for instance, you have that car, it's brand new, every 5,000 or 10,000 miles, that you got to bring that in to get the oil change, right? That's preventative maintenance, that, I'm going to prevent this motor from burning up because I'm going to change out my oil, every 10,000 miles, or I'm going to change out this belt every 50,000 miles, or this filter every X amount of miles. So ultrasound is when we talk about different machines and motors, compressors. Ultrasound is one of those things as well that can let you know that your equipment is starting to degrade. For that, FLIR has an SI-124, and we'll talk a little bit more about this, but our SI-124 is our sonic imager that can pick up this ultrasonic spike in activity. And ultrasound is not something that our human ears can hear. You can't see, you can't even really feel it. So you need an acoustic imaging camera to actually pick that up. Also, vibration. Vibration is another indicator of your equipment failing. And again, if we hop back into that car, you're at 70,000 miles or 100,000 miles, and you're driving down the highway, and then all of a sudden your car starts to shake when you get up to 80 miles an hour. Like, this hasn't happened before. This is new. It's vibrating pretty bad. I'm going to bring this into my mechanic. Or maybe it's your wheel alignment, right? You're getting vibration in your steering wheel because your wheels, your axis is not aligned anymore, right? That could cause vibration. So those are a couple of the early indicators of when your equipment, needs repair or maintenance. If we move on a little further, we also have this preventative maintenance. And again, now we're going to get into, maybe thermal imaging, right? It's hot to the touch. You're getting loud noises. Again, if you're in your car, right, you hear something that you never heard before. And thermal imaging definitely plays a part in this. It's interesting. Thermal imaging is still an early indicator, but it normally comes after maybe something like vibration or ultrasonic spikes. Thermal imaging could actually come after those guys. So, but thermal imaging, the way we use that, and as it relates to your motors and your equipment, is if that piece of equipment starts to heat up and you have a heat anomaly or cool down, something that's not supposed to cool down, you get that heat anomaly, you know that something is wrong. You know it's supposed to be 80 degrees Fahrenheit and it's spiked up to 125 degrees Fahrenheit. You know something is wrong with that. You don't want that to go undiagnosed. You don't want that equipment to continue to run at that heat, at that level. So with the thermal imaging camera, you can pick that up and ensure that you get the correct people out there to do the maintenance on that, to make sure you don't lose that equipment. We'll also talk briefly about IR windows. Excuse me. IR windows are used for electrical panels and switchgear, so you can do more frequent and easier inspections of your of the electricity in your building. For the thermal cameras, it's also, we have fixed mount cameras and handheld cameras that can do these operations. Lastly, we get to the critical failure, right? And this is where you've run this thing to the ground, you beat this thing up, it's your car and it gets to the point where it's going to cost $5,000 to, repair the transmission, but the car is only worth $3,000, right? So you're like, I'm not going to spend $5,000 to repair a car that's only worth, the 4 tires that are on it. So then you run it to the death, right? It gets that critical failure, and or it becomes, unusable in a, utility setting. Maybe that's like a big arc flash incident, something like this that we see, right? And then that's going to disrupt all of your equipment, cause major damage, and you're going to have to replace, a lot, and hopefully nobody gets hurt. So with FLIR, we do have a complete reliable solution to help avoid this situation, and we'll talk about some of those different solutions here throughout the rest of the webinar. So vibration, a little bit, what is vibration? So the different sources. Vibration is on a machine is due to several reasons that may be related to the function performed by the machine, inadequate design, the manufacturing process, the installation, or wear and tear. Machinery, heavy machinery, if you got a press machine stamping out metal pieces, right, there's going to be a certain amount of vibration. Vibration isn't always necessarily a bad thing. Sometimes it just comes with the equipment. But if that, goes out of tolerance, if your vibration is now acting different than it normally is, now you have an issue. But vibration in and of itself is not always a bad thing. It's forces that cause periodic vibrations are the most common. These forces repeat their pattern at regular intervals. Periodic vibration relates to common machine failures that occur at operating speed. So again, if you have a piece of equipment that's operating at a constant speed, and then you get this periodic vibration that jolts it a little bit and sends a spike and interrupts that, that's when you're going to have some of those issues. Another source is in the installation of the equipment, right? And this can be the biggest source of vibration. Misalignment, a soft foot, looseness, are examples of conditions that cause excessive vibration. So if you don't have something bolted to the ground properly, tightened hard enough, that could cause room for error as well. And then you have normal wear and tear, structural damage, and abuse that can modify the function of a machine and can also cause vibration. So from FLIR and X-Tech, if you didn't know, X-Tech is a brand of FLIR. FLIR acquired X-Tech about 12, 13 years ago. So X-Tech actually has some portable vibration solutions. These are going to be used for more like one-off testing. Maybe it's not something that you test every day, or maybe it's more like once a month you want to test it. You can track your results and then compare it to the month prior and the month prior to that. So these are contact portable vibration meters. So we have these solutions available in the X-Tech line. And then again, right, you're going to get some of this trend analysis. So you're going to have your normal vibration, and then maybe you have a spike in vibration, and then also you can set thresholds where, hey, this is where it's really bad. This is where we got to shut the machine off and get one of our facilities guys in here or engineers in here to take a look at the equipment. On the FLIR side, FLIR also recently just launched a new product. We call this our SV87. And this product is going to be used to monitor, do continuous monitoring of vibration. So this is something that you can set up, and then it's kind of one of those set it and forget it things. We have software that comes with it that can alert you when your system is out of line. You're going to put something like this more on your critical equipment. Again, maybe the most expensive equipment, or the equipment that gets used the most often, or the equipment that produces the most amount of goods. And again, this is going to be used to increase your uptime and reduce the risk of injury to people and to the machines. And then again, we can create and track historical reports to see those different changes or anomalies and understand exactly what's going on, when it's going on, where it's going on. Maybe it's on shift 1 and shift 2, this equipment works great. And then when shift 3 comes into the building, something's happening with shift 3. Maybe they're not trained properly on how to use this equipment, and we can see that in a vibration spike, right? So we want to get those people trained to use that equipment more properly. So our SV87, again, is our vibration monitoring solution. As you can see on the slide here, there are 4 little brick-looking devices. These actually get mounted onto your equipment, and then you have the bigger ball, and you can see it's got like a plug right here. This actually gets plugged into the wall. We call this our gateway. So these sensors go onto your equipment, and they can track your equipment via, vibration if it's moving backward and forward, like on the x-axis, if it's moving up and down on the y-axis, and also like on the z-axis going left and right. So it can track and sense all of the vibration that's happening on that machine, and it sends that information to your gateway. And then through the gateway connected through Wi-Fi, it'll send that, and you can actually dig into the software. You can have that on your mobile device. You can tap into that onto a computer and actually see what those trends look like, what those charts look like. And again, if they do get out of line, you can set tolerances and thresholds, and then it can actually send you an alert or an alarm to let you know that, hey, somebody needs to get over there right away. This equipment is not acting as it should. So, who could use this, right? What are the people, or what are the equipment that might use this? So manufacturing, pulp and paper, food and bev, oil and gas, power generation, water and wastewater plants, and then reliability contractors and consultants. Worked with a group just the other week, and they install equipment. That's their job. They're professional installers. And one thing that they like to do is track for vibration, track for thermal anomalies. So they'll use our equipment they install, and they will do condition-based monitoring for about 2 weeks, while now the customer, the manufacturer, has that equipment up and running. So they'll leave the equipment there. They'll do some tests and some trials over about a 2-week time span. If everything checks out, now they kind of know that they've done their job correct. They've installed it and it's working fine. Then, they leave the customer and they kind of say, hey, this equipment is good to go. We've tested it for 2 weeks. Everything is fine. So for them, they kind of use it as reliability and kind of covering their workmanship. And they have the data to back it up. And then also some of those customers, they will actually purchase and say, hey, that's actually a good idea. Why don't we leave that equipment here? You already got it set up. We'll buy it from you and, leave it here to track, because we want to do this throughout the time of the machine and throughout the time of our operations. Okay, so moving on to, again, one of those, another one of the early indicators of equipment degradation is ultrasound. So again, just a couple quick, definitions or descriptions of ultrasound and ultrasonic technology. So ultrasound technology involves using high frequency sound waves, which are beyond the range of human hearing, that are produced by equipment. The sound waves are themselves highly directional in nature and tend to be produced by discrete localized sources. Ultrasonic waves, they tend to be indicative of the equipment degradation. So when we find them, we can use them as early warning signals of future equipment failure, right? And we kind of talked about that in the opening. That's the whole goal of condition-based monitoring. And a tool like this, or an acoustic imaging camera, ultrasonic camera, they're valuable as comprehensive asset management solutions, which are important for helping companies save money, increase product quality, worker safety, all while reducing unplanned equipment outages. So some of the applications for this, and in particular our FLIR SI-124, where they can be used, is electrical partial discharge, compressed air system leak detection, and also vacuum system leak detection. One of the biggest things that many manufacturing facilities have in common is they have compressed air systems in their facility, and it's also one of the biggest energy uses and cost for that organization. So the Department of Energy, they estimate that up to 30% of a manufacturing facility's electricity is consumed for compressed air. So you're turning on the lights, you're heating up, or you're cooling down the office, right? All of that, you're running gas through. Generally speaking, 30% of all of that utility bill is going to come from turning on your compressed air systems. And then on average, a third of compressed air is waste due to leaks, misuse, pressure drops, and overpressurization. So of the 30% that you're spending, a third of what you're actually paying for is going right into the air, whether you have a leak in a hose, or a bad connection at a valve, right? Or using too much pressure, not enough pressure, and so you got to compromise for it. All of that stuff adds up to waste, and that waste is, real dollars, real money coming out of your pocket. And so based on a typical manufacturing facility, if you do have these leaks and they are, going unfixed, it could mount up to, close to $40,000 a year. So if you just seal those up on, a regular basis, because again, it's going to happen. But if you find those and you correct it right away, that's a lot of money that you're going to be able to save. You're going to be able to make a lot of people happy, especially in finance at your company, at your organization. Here's an image of what that might look like. So again, the SI-124, it's super lightweight, easy to use, one-handed use. You can actually just track all the different compressed air lines throughout your building. And then when you do have that ultrasonic spike, when you do have, that leak, it's going to show up like this. It looks like a little rainbow. It gives you that nice target. You can take a picture of that, and then you can actually store it and upload it through our cloud software, and then have somebody, come and do the repair if that's not you. You can have somebody come and do the repair. You can send them this image, say, hey, this is where the leak is. Would you please go fix this? And then you can come back and check your work after. Here's just another example of a compressed air leak. Again, at this connection, maybe it's not tightened enough, and it could be a quick fix, right? Just getting a wrench and tighten it down, maybe getting, sealing it a little bit better. Maybe that's even electrical tape or duct tape, or soldering it shut. Whatever that is, it's probably an easy fix, but all day when this is running, that's just dollars coming out of the hose that you're wasting, that you're losing. Plus, if you're making something and you need 200 PSI, and 200 PSI is supposed to be coming out of this hose, but now because you're losing some of that pressure, now when it gets to the end of that run, now maybe only have 190 PSI. And for whatever gizmo gadget that you're making, that's going to cause bad quality because it's supposed to be 200 psi, not 190 or not 180. So not only saving money, but ensuring that you have consistent airflow through your lines is going to be important as well. The SI-124 is really cool because it also can do partial discharge. So along with the compressed air that it can find, the compressed air leaks, it can also do partial discharge, making it a very versatile tool, 2-in-1. And for partial discharge, what it can find is corona. So this is the ionization of fluid or air surrounding a conductor. Sometimes if you're walking near a power line, right, you might hear that buzzing sound. A lot of that is corona that is in those lines. Tracking as well, so surface tracking, coming over contaminated insulation. There's an image of that right there. And again, right, these things that go undiagnosed usually result in big catastrophes. And then arcing, when you have electrical breakdown of a gas producing a plasma discharge. So if you have some leaks, between connections or connectors there, like an SF6 leak, right? Some of these can cause that arc flash, which again is going to be a bad day for a lot of different people. And then here we have just a couple examples of that. So here's a faulty insulator. Again, you got that nice rainbow image. And then here there's actually artificial intelligence on the software on the camera that will tell you what kind of discharge it is. Whether it's between components in the air, it'll let you know what that is. And then from that, you can use that information to better make your fixes and your repairs or what to do next. Here's a surface discharge on an insulator again, and then here you can see, judging by the ultrasonic spikes that's coming out of this, again, that artificial intelligence is taking that information and it's telling you that there's discharge on the surface or inside the component. When it's inside the component, those are definitely things that you're going to want to take a look at and investigate, and maybe get that cherry picker out and climb up here and see what's going on. The SI-124, it's also good to see up to over 300 feet. So you can do these scans if you are outside doing these predictive preventative maintenance scans, these condition-based scans. You don't have to get up close and personal to everything. You can take those scans from a healthy distance, again, over a football field's length away, either in front of you or above you in the sky. So never really putting yourself in danger. This thing has massive reach. And then here we have, again, like a floating discharge. Now, this isn't going to be as big of a cause for concern. Again, you can see here that the AI is telling us that this is discharge between the two components. And again, maybe something to keep an eye on, but not something that you're probably going to have to worry about right away. So really quick, just a couple quick features of the SI-124. Again, like I said, it can do both air leaks and partial discharge, making it very versatile. It's lightweight, one-handed use. Can operate, over 300 feet. And also, it's built-in Wi-Fi, so you can upload those images right away and get that analysis on the spot. Switching gears really quick to IR windows. So when we look back, or when we think back to those different indicators of your equipment degrading over time, right? It was, vibration, and ultrasonic spike, oil analysis, right? And then thermal anomalies as well. And so one of the things that I want to talk to you today about is our IR windows and how they help with doing electrical panel scans and switchgear inspections. So as we all know, right, when it comes to electricity, there's many different hazards, and there's a lot of different OSHA standards out there, to keep the people in your facility safe. A lot of times, and the NFPA as well, to do this work, you have to wear, different safety suits, You might need 2 people to do an inspection, 1 person to monitor and make sure that the power is off, or that nobody else is kind of stumbling into the wrong place. Another guy to actually be inspecting the equipment. So a lot goes on with these electrical scans, and with our IR windows, we can really help save you a lot of time and improve your safety. So again, the IR windows, they improve safety and your reliability, right? So the cabinet doors stay closed when you're doing these scans. Workers are isolated from the switchgear, so they're not as close to it. So if there is an arc flash, they're not going to get hit by it. And then your risk is reduced on the hierarchy of controls. So if you talk to your safety team, they might have a pyramid like this. And basically what you want to do is stay there at the top of the blue, right? So they look and say, how can we keep our people the most safe? Well, the way you can first keep people safe is by eliminating the danger, right? Well, that's not always an option. So what's best? You could substitute out that danger. You could replace that hazard. You could also isolate people from that hazard. And that's where our IR windows really sit in. They're very high on this hierarchy of controls. Below that, you could put warnings, right? Like, hey, swim at your own risk, right? Type of thing, or don't light a cigarette in this area. Administrative controls, you could try and change how people work. And then PPE. It's kind of interesting that PPE is actually at the very bottom. PPE is, definitely a last line of defense. It's kind of like wearing a seatbelt in your car, right? Well, yeah, you're gonna wear a seatbelt. I wear a seatbelt every day, but I also make sure that, I'm not drunk when I get behind the wheel. I make sure that I'm not going 100 miles an hour in a 25-mile-an-hour speed limit, right? You do all of those things to try and eliminate and reduce and substitute the risk. But then the seatbelt is kind of like if I do everything, if I'm being the most safe defensive driver I can, but somebody else, just barreled into me and I don't see him coming, that seatbelt is, hopefully the thing that's going to save me. So these IR windows, again, they also improve reliability. Because your doors stay closed, your inspections take less time and can be more frequent. And then problems are found earlier and repairs are scheduled and can be improved. And then productivity. These only require 1 person for inspection. You don't need that spot person or, lockout, tag out. You don't need that other person because you're not opening up those doors. You're just flipping down a window. Your man hours are reduced from not having to put on all of the PPE suit up. You don't have to remove the covers and then put the covers back on. It's also easier, more frequent inspections lead to more efficient equipment and less line downs. So the more that you get people in there to inspect your electrical panels and your switchgear, the more likely you are to catch anything that is an issue before it becomes a bigger catastrophe. So here's a couple looks at what these thermal inspections look like, right? So on the left, we see, this guy has to open up this door, right? He has to open up this cabinet. You can see he's in all the NFPA rated suits, right? Because he's got live energy coming out of this thing, and he's trying to take an image of it. The guy on the right, hey, what if you just cut a hole in there and put one of our windows down? Now I can take this with that panel still between me and the live energy. That's going to cause safety between us, right? It's that barrier between the energy. And then visual inspections as well. With all of our thermal imagers, you can do thermal imaging and visual inspections as well. So you can get both images on there. We also have a cost calculator or cost saver. So you can plug in different things, right? The number of thermographers that you typically use, is it 1 or 2? How long it takes to put on this PPE. The inspection time, you have to take the panels off, turn the power down or do whatever you do. Then you got to bolt the covers back on. How long it takes to do all of that. it just calculates all of that for you to see actually how much your savings would be by using our IR windows. And then here's just a couple more images of how our windows are worked. Here's a large format. So if you do have a bigger panel and there's a lot of things that you want to inspect behind that panel, and one 4-inch circle isn't going to be enough, we do have these rectangular windows that can allow you to do broader inspections of those panels or of that switchgear. Right, so what is a thermal imaging camera? So thermal imaging cameras detect IR waves that are emitted by all objects. Doesn't matter if it's a cold ice of water or a burning fire. All objects emit a certain amount of IR radiation, and our cameras actually pick that radiation up and turn it into a temperature value. When you're looking at IR cameras, a couple of the big things to take note of are IR resolution and the pixel size. So IR resolution is how many targets you have, or how many pixels you have on target. So similar to like a TV, you might have a 1080 DPI, right? That means you got 1080 different pixels on that screen that are giving you one nice clear image. IR cameras are very similar. It depends how many pixels you want. The more pixels, generally speaking, the more pixels, the better image quality you're going to get. So you could have a relatively low amount of pixels, and then you're going to have more segmented images, or you could have high pixels and you're going to get a clear image. Then you can see this person's face, right? Like an 8x8 screen, a 16x16, 32x32, 80x64. You could see it's the same person, it's the same image, just coming into more clarity with the increased resolution that you have. So with the IR resolution, the higher the resolution, the greater distance you can be away from the target. Again, because in that field of view, the target that you're looking at, if I have 300,000 different pixels on this screen as opposed to 5,000 pixels on this screen, I'm going to get a lot more detail with the one with 300,000, and I'm going to be able to see that from a greater distance as well. These thermal cameras, they're going to help you with decision making. And again, the stronger the camera, generally, the better the performance and the better the decision making that you're going to get. So when we look at these two images right here, we can see that the hottest spot right here in this box is 98 degrees. Or on this line right here, we can see that the hottest spot is 127 degrees. Now, when we beef up, take the same image with a higher powered camera, now we can see that actually that spot is 182 degrees. So now we have more pixels on this target. That's going to give us more temperature readings, and it's going to give us more accuracy is really what it comes down to, because now we have a smaller target, smaller pixels on that target to give us that actual reading. And then we look at this one over here where it was 127 degrees. Now we put a more powerful camera on it. We see that it's actually 280 degrees Fahrenheit. And so if you took this image, you said, hey, 98 degrees, that's pretty normal, right? This thing should operate at 98 degrees. But you didn't know that in reality it was 182 degrees. Your decision making is going to be vastly different on what you're going to do in those situations. So it's important that you have the right camera for the right application. So this was a 160 by 120 camera, and then this was shot with a 640 by 480 camera. The other thing that plays a big role in IR cameras and IR temp guns and whatnot is the spot size ratio. So what we see here is an example of a low spot size ratio. This is 6:1. So basically what that means, at 1 foot away, you can see a 2-inch target. At 2 feet away, you could see a 4-inch target. So as you get farther away from the camera, you're going to see that ratio, right, increase. So if you have a 6-to-1 camera and you're trying to shoot something like this, maybe it looks like a car motor here, you're actually going to get the temperature of this whole circle, and it's going to give you that average of that whole circle. Again, maybe this is just 3 or 4 inches, but it's going to give you a temperature of that whole area if you have a low spot size ratio. But if you have a better spot size ratio, say a 24-to-1, now that same 1 foot target, you're going to see a 1 foot distance, you're going to see a 1/2 inch target. Or at 2 feet, you're going to see a 1 inch target. So 24 inches to 1 inch, right? So 2 feet away, you're going to see a 1 inch target. So now if we're looking at that same thing, now we can actually get a better indicator of what this hose is actually heating up to, and if that is an issue or not, but it's not going to incorporate everything else that's going to throw off our decision making. So we have some different types of cameras and software that go with them. So one, we have portable cameras, right, or handheld cameras. These range anywhere from $300 all the way up to $50,000 plus. Different performance, different features all along the way. So we definitely have a camera that fits every budget, that fits every application. So FLIR has been the worldwide leader in thermal imaging technology for the past 50 plus years. We still are, and as technology advances and advances, right, we're coming out with more powerful, more feature-rich cameras at better prices, every year. Then we also have fixed cameras. So if you are going to do some condition-based monitoring, something that you do want to look at on a 24/7 basis, we do have fixed cameras that can be hooked up. And again, these types of cameras can send you those alerts, those alarms when something is not as it should be. We also have this kiosk on here. So during this time of COVID and people infectious diseases, this kiosk can actually screen for elevated body temperature, because just like equipment, when equipment heats up, that's a sign that it's sick or failing. Same thing with our bodies. Generally, when humans are sick, they spike a fever. This can actually tell you if you're running an elevated skin temperature or not, and give you a green check mark, hey, come into work today, or a red X, hey, maybe you should go to the doctor and make sure that you're not spreading any disease. We also have software to go along with our cameras, so you can do that reporting and analysis on the back end. So we have different levels. Our FLIR Thermal Studio Pro suite. There's a couple different softwares available in that suite. And then we also have something that's relatively new. It's our route creator or inspection route. Basically what this is, it helps guide you if you got to do a lot of inspections. It helps guide you in the most efficient way to do those inspections. Sorry, I got mixed up here on the slide. So here's an image of what our what our software might look like. You can generate reports. They're very fast. You can make libraries of the thermal image with the visual image, so they're connected together, and then you can put them in these reports. You can put different analysis on here, the min, max, the delta, average temperatures. You can draw different boxes around areas that are of interest. You can do all of that in the software and then share these reports very easily. All of it is non-proprietary, so it's just PDFs and JPEGs. So even if somebody that you're sending this to does not have the software, they don't need it. You just attach it like any other document on an email. You can share it with them. And then also what I was diving into before was our inspection route creator. So if you do do inspections on a regular basis, and you gotta check out 18 different things, and you want to do it in the most efficient way, you can do that with the route creator. You actually plug in the 20 different things into your camera that you have to inspect, and then as you're inspecting them, your camera, pulls up number 1 first and says, hey, inspect this electrical panel. Boom, you take an image, you say, check, got it. What's next on the camera? It says, okay, great. Number 2, you're going to go, check this compressor line or this motor, right? And then it guides you through your day on what you have to inspect. So it helps you in creating more efficiencies in your time. So instead of doing inspections like this, where you're going back and forth, back and forth, back and forth, right? Or maybe you forget something, you're going along the way, you're like, oh, I was just on the east side of the building, but I forgot to do this. Now you got to go back. So instead of doing that and not being, very organized, the route inspector, the route creator, can actually help you and hit your spots in the most efficient way possible, right? Just like driving a car, you want to get from point A to point B in the most efficient way possible. If you're going from, New York, to Florida, you're probably not going to cross into Illinois. So you want to make sure that you're doing it in the most efficient way possible and ensuring that you're hitting everything that you intended to scan. Lastly, really quick, then we'll get to some questions. We also do have training available, training on our thermal imaging cameras, on our acoustic imaging cameras, on roof inspections, right? So we have a multitude of various training classes. In the wake of COVID, a lot of these have gone online, or at least that's an option. We do still have some in-person courses that are starting back up. So you can do in-person courses as well. Or if you want to do it online, we have a bunch of those online as well. You can find this on the Global Test website, or you can go to itctraining.com and you can find information there as well. So with that, I will kick it over to Chris for any questions that may have come up during the training.
Awesome. Thank you very much, Russell. Before we get into any of the questions, I want to thank you very much for the presentation. I hope everyone found it informative and helpful as I did. Quick little recap, or just to figure, to give you a little bit of a reminder. Please try and take advantage of the next 10 or so minutes while we have Russell connected with us. He'll be able to help answer as many questions as you possibly have. So please use the chat feature. Just a special note for any specific product-specific related questions. If you have questions on pricing, availability, technical specifications, we encourage you to visit our website, globaltestsupply.com. You'll find a list of FLIR products that we have, like I said, all the pricing, availability, data sheets, everything that you can find there. You'll also find all our contact information to reach out to one of our technical support staff who can help you with figuring out what the best solution is for your specific application, any questions you have related to that. So we'll open it up. And we did have a few questions that came in. This is thermal camera specific. How would you decide what emissivity value to use when, let's say there's no real specific in this question, but let's say during an inspection, how would you decide which emissivity value to use? And if you can, tell us the difference between reflected temperature and atmospheric temperature. Yeah. I think you're on mute.
Sorry, yeah, I did put it on mute there for a second. Yeah, no, good question. So emissivity, definitely an important topic when it comes to thermal cameras. So for those on the call, so emissivity is, the rate at which an object actually emits that energy. So it's on a scale of 0.00 all the way to 1.00. 1 being basically 100% emissive. There are some different charts on online that you can Google, like emissivity values. So if it's, you're shooting copper or steel or wood, there are some good guides online if you just look for those different charts. Some of our cameras do have some of those values built in. Say like wood is, 0.8, electrical tape, right? Like electrical tape is one of the best ones out there. It's like a 0.98 or a 0.99. So you could definitely do some research on that. If it is like a shiny material, surface material, those tend to have lower. So if it's something that's dull or something that you could paint over, black paint, are some quick fixes if it's safe to do so. Again, like electrical tape is something that's very a good emitter as well. And then what was the second part of that question again, Chris?
That would be the difference between reflected temperature and atmospheric temperature.
Gotcha. So then reflective temperature, right? So if you point an IR camera at a window, for instance, like a glass window, not one of our IR windows. Our IR windows are made with a special crystal, germanium crystal, that allows the IR sensors to pass through. But on like eyeglasses or a glass window or a car windshield, any of those things, you're actually going to see a reflection. So it's going to hit that surface. It's like us looking at a mirror brushing our teeth in the morning. An IR camera will hit that window and actually bounce back. And it's actually going to give you a reflection. It's going to take the temperature of, if I'm standing right in front of it and I'm pointing it, horizontally to the ground, it's going to hit that window. Then it's actually going to give a temperature reading of my body, if my my face or my body's in that field of view. So that's going to give you that reflective temperature. And then atmospheric temperature, in the cameras, when you're using the cameras, you can also say, hey, I'm in this warehouse and it's in, Dallas, Texas, and it's July. Hey, it's 115 degrees inside this place. You can actually set the atmospheric temperature on your camera to like 115, and that's just going to help with the accuracy of the reading. Likewise, if you're in a cold environment, you can dial that back down. Probably by default, a lot of the cameras are shipped like room temperature, like maybe like 68 or 70 degrees, but you can adjust the atmospheric temperature as well.
That's perfect. So quick reminder, we have a little over 5 minutes to get to as many questions as we possibly can. So please don't be shy, use the chat feature. Another one that came in, so this is, I guess, well, it's not really a three-parter, but SF6 leaks, can they be detected via thermal imager, ultrasonic, or do you need something specific where we get into kind of a higher end type of camera where it's specific to the gas?
No, that's a good question. Generally speaking, your ultrasonic camera and your regular thermal imaging camera are not going to pick up an SF6 leak. Potentially your acoustic imaging camera could, if the leak is, big enough. But if it's that big and it is getting picked up, it's probably definitely needs attention right away. Probably the best tool to use would be one of our gas finding cameras. We came out with a newish camera. It came out about a year ago. It's called our GF gas finding GF77. This is actually a product that you can find through Global Test Supply. Our GF77 is also a really cool tool because it can do a multitude of gases and it can also do thermal imaging. So if you're looking for a solution that can do both thermal and find your SF6, and you want that to be a thing, I would definitely go with the GF77. We have different lenses that you can put on it. We call them low range and high range lenses, and depending on the lens that you're using, you can find SF6, methane, different refrigerants out there as well. And they're all interchangeable lenses, and all the lenses also do the thermal. So again, it's like a Swiss Army knife, right? It can find like 10 different gases and it can do thermal imaging. It's a great tool for you to get your hands on or request a demo. SF6 is one of the, and then just I guess to clarify and answer, SF6 is one of those main gases that camera is meant for. So it actually gives a pretty good image when you come across those leaks.
Absolutely. Let's see, moving on. Well, I guess, you know what, this is a great segue because we did have a question come in about this. Can we detect refrigerant leaks with the SI-124, let's say, as the example?
Yeah, good question. You know, again, it might pop something if that leak is causing an ultrasonic spike. Some leaks will, some leaks won't. So it's not always going to be you know, like a foolproof. But that GF77, or we have other gas finding cameras by FLIR that are, you know, could be more specific towards a certain refrigerant that you're looking for, would be a better solution for that. But I'd check with the GF77 first. You know, that might get you what you need. Plus, it's going to give you a nice thermal imaging camera to doing, you know, all your other predictive preventive maintenance as well for thermal monitoring.
Perfect. So one last reminder, got about 2 minutes. Get in your last minute questions through the chat feature. If, you know, between now, wrap up a few minutes after we close things out, question comes up in the mind that you weren't able to get out right now and today, go to globaltestsupply.com, our contact us page. You can find all the ways that you can contact our technical sales support staff, and you can contact us with any and all questions that you have. We can direct you to the best solutions for your application, get you, you know, all the information that you need. Let's see. We'll do one more question. So what would you suggest in terms of HVAC monitoring? Can an ultrasonic camera be used for HVAC monitoring, or would you simply, you know, go with thermal image depending on, I guess, what exactly they're using it for? But I guess in a broader generic range, can both be used in an HVAC type of application?
Yeah, I would say probably your thermal camera is going to be better for your HVAC. Obviously, with the HVAC, you're looking for, you know, if the heat or the cold air is coming all the way through, it's probably not moving as fast as like you know, like the sonic imager might pick up. So I don't think it's going to cause those kind of disruptions, those ultrasonic spikes. So definitely with HVAC monitoring and testing, probably go more with definitely with you know, thermal imaging cameras. You know, so you can point those at your at your different returns and your vents coming out of the floor, see what you have coming on, or, you know, through your duct work if you're worried about, you know, connections there or seals there. You can find any of that heat escape or cool air escape as well. There you're going to be looking for more the temperature differences, so I would lean on the thermal imaging camera.
Perfect. Well, that brings us right to the end of our hour. So I will thank you, Russell, very much. Thank you again for the presentation. Very informative, a lot of information there. So thank you very much.
Yeah, absolutely. Thanks for having us, and thanks for the questions. You know, obviously wanted to go over a lot of the basics today. You know, got a little more in depth in some things, but you know, definitely if, you know, any of this spiked your interest, reach out to Global Test. They're great. You know, they got certified thermographers on board. You know, and we're happy to help get demos in the field as well. So our equipment really sells itself. So definitely reach out.
It most definitely does. So on behalf of Global Test Supply University, we thank you very much for attending our webinar today. We hope, as mentioned, you found it informative and helpful. Global Test Supply are here to assist you in any way. Simply go to our website, globaltestsupply.com, for anything that you need. Through our website, you'll find our entire list of FLIR products with descriptions, specifications, pricing, availability. We also have a few availability for rental as well. You'll also find, as mentioned earlier, our contact information and the many ways that you can contact our sales support staff and technical support staff so that we can answer any and all questions that you may have. In just a couple minutes at the end of this webinar, we'll have a short survey that we'd like you to complete. Your feedback will assist us in improving and allowing us to bring you more topics of interest for our upcoming webinars and future webinars. Speaking of upcoming webinars, we do have a few in the next coming weeks and months. So if you visit our training section on globaltestsupply.com, you'll see our full schedule of the upcoming webinars, dates, and topics. Don't forget that as a thank you for attending the webinar today, your name will be entered into a draw to win $100 on your next online order. The winner will be announced through our social media channels, so please be sure to check us out there. Once again, thank you, Russell, for the presentation. Thank you all for joining us today. Wishing you a great rest of the day. Stay safe, and thank you very much again.
Thanks, Chris. Appreciate it.
Thank you.